Hi everyone, welcome to Tom's Manshed. Now I recently did a video about different materials to print some new dual colour filaments I'd never tried in 3D printing. If you're interested in 3D printing and all the different things you can do with it, click the little card up here. But during that video I was demonstrating the properties of one particular filament, which is one that turns a different colour under ultraviolet light. So when you take it out into the daylight or shine an ultraviolet torch on it, it turns a different colour. This is it here. I'll go into detail at the end and show you the difference between these two torches that I'm reviewing in this video on how they change it, but you'll see how good it is. It's like a little, well, whatever you want to make out of it, a skull. And it's picking up a bit of ultraviolet light through the window. That's why it's going pink, but as soon as I shine this ultraviolet torch on it, watch how good it changes colour. So you see how instantly that changes under ultraviolet light. So during that video I did ask if anybody wanted me to do a review on the different ultraviolet lights you can get, just ask. And one of my subscribers, Joe from Australia, did say, yeah, Tommy wouldn't mind a review on them, so here it is. So basically it's a review on these two torches. One of them, my older one, is a 395 nanometer UV torch. The other one is a 365 nanometer UV torch. Now I'm going to fully explain and demonstrate the differences between the two of them and tell you why, for absolutely everything really, I can't think of any advantage of this, why the 635 nanometer is better for ultraviolet things than the 395 nanometer one. So first of all, let's have a look on Amazon now and I'll show you the two ones I bought. Okay, so these are the two that I'm reviewing in this review on Amazon. So you can see this is the 395 nanometer one. I bought this 3rd of September 2018, so nearly 4.5 years ago. And you can see there it says high, low and strobe. Like I say, mine only has the strobe and the high. And here's the pictures that shows the spread of visible light around it, so it's sort of quite accurate, showing you it zooms in and out, the size and everything. And the other one that I'm reviewing in this, the better one in my opinion, the 365 nanometers, if you look there at the top, black light. So if you see that black light, that usually entails it's like pure ultraviolet light with no visible light. And that's that. Now you can see that that's what was that other one? What other one was that's $6.99 now. So that's today's price, 30% off. It's normally $9.99, but that's $6.99 today. And this one is normally $15 and down at the moment at $11.49. So you can see about twice the price for this. But USB charged, so you've no batteries to buy. You can see there the blocking filters to block out ambient light from other colours. So we're just getting pure UV. It shows you there on that the cat's head, throwing quite a lot of purple light around, but it's not like that. It's any straight ambient light coming out of it is more of a white colour. And there's it showing it charging. Red is charging, green is full charging. Size of it and what it does. Yeah, you can see the toilet there. That's why I didn't show you mine. It was similar to that, even though it looks spotless on the outside. So yeah, that's the two that we'll be reviewing in this review. So as you saw there, I bought this one 3.5 years ago, and I've only just bought this one last month. So I'll just show you in detail now, in close-up on the desktop. So this is the first one I got, and as you can see, they're both roughly the same length. This one zooms in and zooms out. I'll show you that in a second in use. This one, there's no zoom function on it. This one, you've got a clip on it. Again, this one you haven't. On the older one, it's just a one single AA battery. Sometimes batteries have their advantage. If you can swap instantly, you don't have to wait for it to charge or whatever. But this one is USB-C charge. And if I plug a USB-C lead in it, you'll see when it needs charging, it goes red. So when it's running flat, you'll see the red light come up on here. When you click it in, it shows red. And then when it's ready, it goes green. So I'll show you that better in these two photos. So as you can see there, the red light, it's not as bright as the green, but it is visible there, sort of through the slot behind the button. And this is the green one. This is how it displays when it's fully charged. The green one seems a lot brighter. And when it's unplugged, ready for use, there's no light showing at all. And you've just got your one click here on the back. This one, the original one, it says in the Amazon instructions low, high and strobe. Well, on mine it just seems to be high and strobe. I can't remember whether I did have a low setting and it broke or not, I don't know, but I've only got strobe and high now. Strobe's absolutely useless. You don't need strobe on an ultraviolet light. The only time you need strobe is if you're like out camping or something to attract attention of a helicopter for rescue or something like that. They'd see a flashing light in the distance. They're not going to see a flashing ultraviolet light. So click it once. So that should have been low, and I've now got high. So I'll come up from desk view now, and if I shine it at the camera, you can see how bright it is. And now on this one, that's shining, believe it or not, directly at the camera. There, and it's much dimmer, giving out much more ultraviolet light, but much less visible light. So yeah, let's have a look at them actually on the desktop now, and you can see the difference. So here on the left is the 395 nanometer one. Here on the right is the 365 nanometer one. And like I say, you've got the zoom facility on this, so you can zoom right into a sharp thing or right out. That is about the equivalent, I think, of that. Or maybe a bit less to try and get it so that it's a fair playing field. Yeah, that's about right. So as you can see on this pink surface, we are getting some visible light showing on this. But as we move over to the white here, you can see there is no visible light from the three. Very, very little. You could probably say a bit as a whole thing, but a lot more from this. And as we move it around like that. On black, again, hardly any visible light from this, but loads on any colour from this one. So I forgot to show you just then, the new one. Obviously I've long ago lost the box from the old one, I don't know what that came with. But the new one comes in its own little box with a lanyard, should you need it. I never will. And a USB-A to USB-C charge lead as well. So that's what the new one comes with. So before I show you them in action and show you how much better the 365 one is than the 395, I'll just explain. I've done a little time graph here, and just before, I've just recorded a little bit now explaining the difference between the two, and just showing it on a little chart what the visual spectrum is and what the ultraviolet spectrum is. So let's have a quick look at that now. Okay, so I do like science, but as you can see, I'm absolutely rubbish and always have been at art. So I've done this little diagram. Hope it explains it in the sort of pretty much layman's terms. So this is like represents the whole of the electromagnetic spectrum. Right down at this end are radio waves, which are measured in meters, and the lowest of them is like 1,000 meters, very, very low frequency. And then right up at this extreme end is X-rays and gamma rays being the top, and they're measured in like a 0.01 of a nanometer, which is an angstrom. And round about here, or wherever along that spectrum sometime, is what you call the optical light spectrum. And that is measured from 700 nanometers at red down to 400 nanometers at violet. So you've got your colours of the rainbow: red, orange, yellow, green, blue, indigo, violet. I've got them all there. And then, like I say, anything this side of the visual violet is ultraviolet, and anything that side of the red is infrared. So these two curves here, the blue one and the purple one. The blue one is the 395 nanometer torch, and the purple one is the 365 nanometer torch. Now, like I said, the optical spectrum at ultraviolet ends at 400. Anything lower than that is classed as ultraviolet. So you might think, well, how come I can see some visible light in the optical light spectrum from the 395 torch? Well, that's because that 395 that they give you is like an average measurement that there in the middle of the peak. So it goes from further along, sort of like probably like, I don't know, 375 something, right up there. But as this side comes down, it dips into the optical spectrum. So it's probably sort of like 410 or something nanometers here, and that's the optical violet light you're seeing, not ultraviolet. The bright glow around that you see like the beam of a torch is the optical bit of the spectrum you see in the actual violet light. The 365 nanometer torch here is in the ultraviolet spectrum, and it starts and ends in the ultraviolet spectrum. As it comes down here, it doesn't touch the optical part at all, it's outside of it. So the whole of the thing emitted by the torch is ultraviolet, and on the 395 torch it is dipping into the optical thing. You will get, as I explained earlier, you'll get a slight bit of stray light coming out of the LEDs. That's just due to manufacturing. And that's what the very dim white light you see around it. But it's not enough to overpower the ultraviolet capabilities of it. So that's why this torch will show a big purple glow around it, and this one won't. So hopefully that explains why one of them does give a lot of leaked optical light. I know I repeat myself a lot during this thing, but many people think that when you're looking at that bright violet ring of light, that's the ultraviolet bit, but it's not. The human eye can't see ultraviolet light. What you're seeing there is a bright violet light, and the problem with it is it's so bright that it can swamp out any fluorescing materials underneath, any tiny specks. If you were a forensic scientist, I mentioned this at the end of this video when I'm doing the bacteria on my microwave and that, but if you were, say, a forensic scientist looking for blood, semen, urine stains or whatever, and you wanted to pick the tiny ones out, you wouldn't be able to do it with this torch, because the optical part of it would swamp it all out. It's fine for doing stuff like this, like I said, and making your ultraviolet, making your luminous stuff on your watch glow, and glow in the dark stuff for recharging that. Much better than holding it under a light bulb, but nothing like as good as this. So I've done a couple of tests, just shining it around this shed on various objects in the darkness, And again, in the kitchen, using it for something you'd more practically use it for, sort of checking for bacteria on a worktop and appliances and things like that. So first of all, let's have a look at it. I did this the other night, just sat on my comfy chair behind me, shining it around the room and filming it with my camera. Now, you can imagine it is pretty difficult filming it. Obviously, I'm just using a digital SLR to film it, and you can't have it set on auto because it tries to compensate for the light, and it's not an even playing field what the human eye can see. So I had to set everything shutter speed and aperture separately. So if the picture looks a bit grainy, that's why. It's because it's so dark. But I tried to get it so that they seemed just what I was seeing with my naked eye. And you will see in this how this can illuminate some things that this can't, and how much better this is. And then again, we'll see it at the end in the kitchen. So let's have a look around this room at night first, using the two of them. Okay, I'm just squeezing this bit in because I forgot to say, but I will be putting affiliated Amazon links to both these torches under the description below. So if you do click on one of them links, it takes you to the required Amazon page, and if you buy anything from that browsing session, I do get a small commission. It's only pennies per item unless you buy something worth thousands of pounds, and it all keeps the channel going. So if you are going to buy something, it'd be great if you could click on one of them links. Also, during the video, whenever you're viewing footage of one of the torches, I will put at the top which one it is you're watching, whether it be the 395 Newton meter one, nanometer one, or the 365 nanometer one. It just saves somebody coming in halfway through a video, viewing one and not knowing which it is, and viewing, say, the bad one and thinking it's the good one. So all times, top left or top right hand corner, there'll be a 395 or a 365 logo telling you which is which. So start off on the top shelf here. That's the spaceship Liberator from Blake 7, and as you can see with the 395 one, it's illuminating everything, the wall behind it, the coving. It's fluorescing the tail of the engine part of it, the green bit, and it's fluorescing that skull made of rainbow filament, all four colours, really well. That one next to it, that one is a glow-in-the-dark one, and you can see it's illuminating everything up, the coving, like I said, the wall, the shelf. So even though things under ultraviolet are fluorescing, a lot of it is reflective because that's so shiny, and it's reflected reflected violet light, not anything fluorescing on the ultraviolet. So here's some just printer paper on me paper. Now here's this really shows the difference. These are my trainers, and this is with the 395 nanometer one, and you can see it's glowing the eyelets and the laces, but the white of the trainers, it's just illuminating purple, and again it's putting a purple splodge on the carpet, but not really showing any bits that are glowing on the carpet. Now compare that to, well, this one. This is the 365 nanometer one. You can see that the motor there on the Liberator is totally illuminated, but the rest of the model isn't. So it's only the ultraviolet stuff that's reactive stuff that's giving it off, and you see the skull there on the rainbow filament is really, really bright. The glow-in-the-dark one is reflected it much better. It's not glowing, that's not glowing, that's actually just showing the ultraviolet bit. And again, the objects underneath aren't really showing anything, so it shows that other was just reflected light. Here's some same white paper. You can see more markings on the sound knob thing behind. But look at the difference here on these trainers. The white sort of like front of the trainers, it looks black. It's totally absorbing all the ultraviolet light, not reflecting any of it. And the reflective bits, the eyelets, the laces and the stitching is really fluorescing there under the ultraviolet, but they actually look black. I'll show you shortly. They are white, them trainers. And again, the bits on the carpet, I've purposefully not hoovered the carpet. All these bits are bits from 3D printing and stuff like that. And again, you can see on the carpet, here's with the 395 nanometer one. It's not showing any of them bits. And again, the 395 one, they're luminous stickers on my waste bin under the desk, but you can see it's glowing the skirting board. None of that is fluorescing, all that is just reflected violet light. Well, this is the paint racks behind me. As you can see, it's glowing, and very white top's pretty good, but again illuminating a lot of everything else as well. See the door, that paint, it's not true sort of like white, it's quite old, and it's showing that up, so you can see the door behind the two posters because of the visual spectrum coming out. Now compare that to the 635 nanometer light. Even the plastic on the boxes is fluorescing a lot better. And you can see that alien poster, all the white bits are, but the door looks black. Look, it's totally absorbing the UV light. And you see how reflective that picture is. The redness on the left is just being picked up by a camera. Don't know what it's to do with the sensor of the camera. I can't see that with the naked eye or whatsoever. But you can see all that's picking up is the poster on the door, not the door itself. And again, back to the other one, the 395 nanometer, that is flooding the door with violet light as well. So I think you clearly saw there how much better the 365 nanometer one is. The thing that amazed me is that last bit on my trainers. As you saw with this one on it, yes, things did fluoresce, the red stripe and the bits around the laces or whatever, but the actual white of the trainers were illuminated purple with this. On this one, it totally absorbed it. They were black, and yet this is what the trainers look like in daylight. So they're all white, but on this one, it totally absorbed. I won't be able to demonstrate it here and thing, but you can see the yellow, the blue is fluorescing and that, but nothing from the white of the trainers. The laces, yes, and stitching, yeah, you can see it on the stitching, but the white material itself totally absorbed the ultraviolet. And in the black, it looked black. Put this one on. See, it's not showing the fluorescing up anything like as good, because the tiny bit of fluorescing from the stitching, and that has been swamped out with the visible light. So that's that. So finally, now let's have a look what you'll probably use it for more in real life. I know a lot of cleaners will probably use this, and you might use it in a hotel room to check the bed. You could get too fastidious. I mean, like I said, this bit in my kitchen now, okay, I'm not the world's cleanest person, but it's not a dirty kitchen by any means. I would say it's just your standard kitchen. I do clean it regularly, and it looked to the naked eye absolutely clean, as did my bathroom, my toilet bowl. But I didn't want to, like I mentioned in the Amazon bit, I didn't want to film that because it really did look awful, even after cleaning. So you can get two on top of you. I don't think you can get rid of every tiny bit of bacteria without probably some industrial strength chemicals. I tried neat bleach, I tried kitchen top cleaner with bleach in it, and still there was bits left. So I don't think you'll ever get rid of it. So don't get too uptight about getting everything clean in a hotel room or whatever, you're bound to pick things up and it'll look worse than it really is. So, but yeah, let's have a look now in my kitchen and I'll show you exactly what I mean. Right, now this is the 395 nanometer light, the one that puts out loads of visible light as well, on the side of my freshly cleaned microwave. I've only just cleaned this thoroughly. It really does look clean to the naked eye, but as you can see, it's picking up nothing because there's so much visible light. Anything fluorescing under ultraviolet, any bacteria, is being swamped at now by the amount of visible violet light. So even though it will be fluorescing under there, you're not being able to see it. Now we're straight now into the 365 nanometer UV light, and look at the difference. Look at all the bits on that. So this is freshly cleaned. Looks like a new one from the outside. I think I forgot to record it in daylight, but I can assure you it's really clean. But look how much it is picking up. So I'm getting that red reflection. The camera picks up a red reflection sometimes. You can't see that at all with the naked eye. But you can see, because there's so little visible light, the white circle you can see is so dim that the fluorescent bits are showing through it, so it's not obscuring them like the other one. And you can see all them scratches on the worktop that get bacteria in them. And yeah, like I say, it's all cleaned. This I've just freshly cleaned it, and yet still there's all this, I presume, bacteria in it. And that's the same spot with the 395 nanometer light, with all the visible purple light. You can see it's just not picking up at them scratches at all. So any forensic work you're doing, blood, semen, urine or whatever, is being swamped out. So there you have it, pretty conclusive proof that the 365 nanometer is much better bet for doing ultraviolet detection of things that fluoresce. As I said before, fine for other things. The only advantage I can see on the 395 is because it does give some visible light, you could use it as a torch at night. So if you were coming home in the absolute blackness down a back alley or something, it would illuminate the non-ultraviolet things to some extent as well, but very poorly compared to a proper torch, proper flashlight. So, but if you just wanted to buy something for its ultraviolet capabilities, I would definitely say look out for the 635 nanometer one. So before I go, I'll just show you again on this how they do both work, but how one is better than the other. So I've got both turned on now because it doesn't take long to react. So I'm going to quickly get it up. First of all, the 395 one, and count maybe 2 seconds and seeing how much it makes it turn red in that time. So let's have a try now. Try and get it. So I'll do this bit first. Right, here we go. 1, 2, 3. 1, 2, 3, 4, 5. Right, that got it like that. That was a quick count to 5. If I hold it on longer, it'll do it if I hold it on longer. So the other side now. And 1, 2, 3, 4, 5. See, much better. And if I hold it on longer like I did the other, you can see how much better it gets than this one. So much more UV given out by this one. So hopefully this has been of some use to you if you're contemplating getting one of them. Take a look at Amazon and various other places. The word blacklight, I forgot to mention it earlier on, but you'll have noticed on the Amazon clip I showed you of this one, it said blacklight for this as well, which to me is not a blacklight. Many, many years ago, I ran a mobile disco, and all through the 90s, 87 till 99, and very trendy in the 70s and 80s was a UV fluorescent tube, blacklight tube that made everybody's white bits glow as soon as they walked in the room. Now that was a proper blacklight, like this. Didn't emit any daylight, any optical light at all. To class this as a blacklight, I don't think is right. It's just a UV light. Anyway, enough of the waffling there. So I hope again it has been of some use. If it has, please give me a thumbs up. If it hasn't, by all means give me a thumbs down. If you haven't already subscribed, please do so. It would be great if I could get some more subscribers. Do so by clicking the little picture here of the shed on the left. And once you've done that, if you click the little bell icon below, you'll get informed of any uploads as soon as I do them. So once again, thanks for watching this one. Hope to catch you for the next one very, very soon. Bye for now.